Good morning, good afternoon. Thank you for joining us. March's TBC Power Hour on COGO routines in TBC. We're going to have some fun here with Trimble Access and TBC as well. I'll be your host, Joe Blecka. I'm the product manager for TBC here in Westminster, Colorado. These are my two little ones. Been in Colorado for about 4 years now. Haven't been to the slopes yet. These two I'll use as a not really legitimate excuse, but a cute enough excuse. We made it to Steamboat a couple weeks back, got to see the mountain, didn't get to go up on it. So maybe at some point here soon, be able to hit the slopes out here in Colorado. Our agenda today, we're going to go through some COGO routines, talk about COGO routines in Trimble Access, and then COGO and CAD routines in TBC. We've got a lot of content, and so I've got a couple of maybe bonus features at the end, depending on our questions and how our timing is done, and see what we can get to here over the next hour. Heavy demo, and I will try to speed up this PowerPoint slide as well. Apologies, I don't have any special guest hosts with me today. Please bear with my very dull and boring voice, and I will try to keep you awake and entertained. At the end of the demo, we'll go through some Q&A, and then, like usual at the Power Hours, we'll talk about resources and next steps. Hopefully I've spurred some questions, some interest, and we'll talk about what's available for you to find out more. All right, first up, quick overview of what we're going to be doing in Trimble Access. There's a very popular function in Trimble Access General Survey called the COGO routine. I will go through in Trimble Access and then show the equivalents in TBC. 5 of those routines: compute inverse, compute point, compute average, transformations, and subdivide align. Then the equivalencies in TBC: compute an inverse with the added functionality of an inverse report, computing points using the create point command, and the little kind of semi-hidden drop-down. There are 26 different COGO routines in TBC. One of the motivations for doing this topic and this Power Hour is the feedback that people love the COGO routines in Trimble Access, and they say, hey, how come TBC can't do them? We want them in TBC. And while they're not exactly all the same, everything that you can do in the COGO routines within Trimble Access, there is an equivalency on the TBC side. So that's what we're going to be showing primarily today. Go through some computing average routines with some average merging and exploding of survey points. Then showing you the transformation routine, both on the COGO survey point side and potentially the CAD side with moving and translating and rotating objects. And then talk about the creating at intervals command and the relatively new divide line command in TBC. All right, jumping right into the demo, I will be showing Trimble Access 2017.11. I had to pop my head over the cube yesterday to make sure that I was running the latest Trimble Access. I was not aware that there was a 2017.11 recent upgrade. So if you've got your valid warranty, suggested running the Trimble Installation Manager utility and update to 2017.11. And then on the TBC side, everything I show today will be incorporated into TBC Advanced, and we are working with the latest version, which is version 4.00. Yeah. Okay, jumping into Trimble Access. Here in General Survey, you'll see the COGO routines. Oh, excuse me, before I get started, like with any of these Power Hours, please go ahead and type in your questions. We are logging them. At the end, there should be enough time to discuss them and bring them up. If there isn't, we've got your contact. We can reach out to you offline and answer any questions that you may have. All right, so with that, we'll get into General Survey and the COGO menu. Here we've got these lovely features. I want to start with computing an inverse. And this project here that I've got is a mix of GNSS and total station data. We'll be working with the same project within TBC as well. So we'll get a little bit more familiar. It's here you can see this is in US survey foot. Sorry for all of our metric listeners out there today. Where the scale bar here is about 200 survey feet here. So not a super large project, not a whole lot of data. There's one RTK setup with a base point at 0.400 over here, 2 resections, and then a station setup as well. So, compute inverse. It is direction dependent, 2 ways to enter in information. From point, I can say 121. To point, if I wanted to go to 120, I can use the interactive map view, select it, and my inverse is automatically computed. Now this says azimuth grid, horizontal distance grid, vertical distance, slope distance, and grid because I have set my project up in jobs, property jobs, to have the COGO settings set to grid. That's why these display in grid. See in the second page of data here, we've got a delta north and delta east grid value as well. So moving from, inversing from 0.121 to 0.120 deals with these values. I can say store. And if you're not familiar or just getting into Trimble Access, a really handy feature to shortcut it here in favorites, also available in jobs, is this review job. And this is everything in our project and in the order that it was performed. So here at the bottom, check the COGO settings here right before I had signed on with you. I've just stored my inverse. Here it is, starting from 0.121 to 120. You can always come back to this review job and check out the azimuth and distance values from your inverse routine. All right, moving on to the next routine in COGO, computing points. So this is to actually compute and create grid points. I can give a point name. I'll say point 15 is fine. If I wanted to code it, I can enter a code here. I'll call it BD to correspond to my method, which is going to be bearing and distance. There are 9 different options here, I believe, if I can count. Yep, 9 different options to how to compute points directly within Trimble Access. Bearing and distance up top, maybe the most common one. You can pick a start point by using this drop arrow to the right, or picking freehand in the map view. Select your azimuth origin. We're going to go with grid, and then define your azimuth as well. You can type that value in, or I want to show you the calculator functionality in Trimble Access. This doubles as a regular old calculator and conversion tools. You can see here converting from degrees, minutes, seconds to decimal degrees, for instance. There's also these handy features down below of azimuth and distance. If I didn't know my azimuth that I wanted to compute, I can specify to compute the azimuth in the calculator using these methods. What I want to do is compute a bearing and distance at an interval between 121 and 131. So I've got started out from 0.121 to 0.131. I've got a grid computed azimuth that shows up in my calculator at the bottom line. If I click accept, that value is then back into my compute point routine as my gridded azimuth. I can specify a delta off of that if I wanted to. And then on the second screen, I can specify how far along I want to compute this point along this azimuth from 0.121. And I'll say 500 feet, no vertical distance. And I say calculate, it will store as a grid point by default. That's cool, we're working in grid. And at 500 feet, it puts my point 15 right about close to 131. If you wanted to compute a center of your project, for example, for any localized projection, if you wanted to get into ground coordinates and needed a project location, I would recommend using this bearing-bearing intersection. And how we do that, I want to take the extent of my project to compute more or less a center point. You can also take all the points and average them together, perhaps in TBC. But in Trimble Access, you can use a bearing-bearing intersect, select point 1, add a specific azimuth or grid. I'm going to specify, I'm going to go all the way out to 103 from 121. Use my calculator function again from point 121 all the way up to 103. Okay. Accept. I've got my azimuth. Accept again. Point 2. I will start at 131. Go across my project now to 101. Again, using the calculator to compute an azimuth from point 131 to point 101. Accept that. Accept again. So I've got my starting points, my azimuths from those points, calculate, store as a grid, and it creates point number 16 where the intersections of those two bearings. I could use that then as my project location, for example. All right, getting into routine number 3 I want to show today is the average point. Back in COGO, compute average. This is a COGO routine, so we're computing the average of a point. Why you'd want to do this is if you had multiple observations to a single point. So for example, I know point 102 has a couple of different observations to it. How I can find that out if I'm not familiar with the job, or how I want to show you another handy feature of Trimble Access is our point manager. Go up to point 102, expand it, and you see a list of 2 coordinates. We've got this first coordinate, which is a grid coordinate. I know that by that little round symbol and years of support within Trimble Access. And then the second observation is a phase 1 total station observation that reports this coordinate. You see that the grid coordinate is holding. We're at the northing of 4.997 and easting of 0.026 and an elevation of 3.050. Slightly different from these values below, a couple thousandths different with northing, 3/10 different, different in the easting. And oh wow, looks like a bust here, 17 or so feet different in the elevation. I use the average point command to merge those two together. In the options, the averaging can be weighted or unweighted. I'll have you reference the Trimble Access help file for a little bit more information on how the weighting is applied. If you just did unweighted, for instance, it would be a simple average of the two. Hit store, and now back in my point manager, I will see that the reported coordinate 4.102 is now the average of my original grid and my original phase 1 total station measurement. All right, moving along to transformations. Any data here can be rotated, scaled, and translated. So if you needed to, for instance, move that point 400, that base point, or if you needed to kind of fake in or get in a site calibration, this is the same exact thing. It's equivalency to a site calibration where you're fitting a selection of data to maybe a series of points. How I can do that for simple demonstration, I'll just use the translate tool. Two different methods for translation. You can use deltas or 2 points, so like point pairs. If I wanted to move, for example, point 400 to point, so you pick from our list of points here, to point 101. I know 101 is close by. It'd be a delta in the northing, delta in the easting, and delta elevation. Say next. That is reading the delta. So then I need to go in here and add my point 400, point that I want to move, to my point list. Say accept, apply the defined transformation, yes, confirmation that that's been applied. And back in our map view, you'll see that now point 100 and point 101 and point 400 are now more or less on top of each other. Very, very simple application. This transformation is extremely powerful in Trimble Access, and I'm excited to show you what we can do in TBC as well. All right, last one, and then we'll get into TBC. This is a TBC Power Hour. Waiting for the TBC stuff. It is nearly here. Subdivide a line in the COGO routine. This is a routine to really create COGO points. Despite maybe what the name implies, you're not actually editing any line work. You're creating a line or modifying a line and creating points along those lines. You can offset that as well. So I wanted to show this routine because it's specifying a line name. You can draft line work in TBC or in Trimble Access directly. If I, for instance, wanted to draft a line between 121 and 120, I can select the 2 points in the map view, press and hold, and say key in a line. I can give this line a name, a code if I want, my 2 points, start station, all these different parameters, sure. Let's just click the store. Now, creating points along this line for maybe perhaps stakeout, you can go back into subdivide a line, pick your line, and pick your method, fixed segment length or fixed number of segments. If I wanted to equally subdivide this, I can do fixed number of segments. I'll say I want 4 segments between points 121 or 120 or along line C. And giving me an offset them from that line at a 50-foot right interval. Page 2, you can specify a start point name. I'll say 10,000 if I needed a point code, and an auto point step size so I can increment custom. Start, confirm, and oh, nice. I've got a series of new COGO points. Now, all of these things are quite powerful in the field, and now it's time to jump into the office side with the same data with a little bit more information that we can show just in the office platform, a little bit more real estate here in TBC. So instantly, right when you see, there's these colored lines. And if you're new to TBC, or if you need a refresher, I said before, there's one GPS setup, one RTK setup with a base point of 0.400. These blue lines are the RTK vectors. I can confirm that with you. by clicking on them, right-clicking the properties. These are RTK vectors. The dark green lines are total station observations. So I said there was one station setup and 2 resections in this project. And then the lighter green, or the lime green, apologies to the color impaired individuals out there we may have, are mean angles. Mean angles are computed from field data when collected in phase 1 and phase 2 observations. Those will be meaned into a mean angle in TBC. The equivalent on TBC for the Trimble Access review job is a new to TBC version 4.0 feature, actually 3.9 I think is when we added it, in history log view. And what history log view is, docket down below here, is as you compute and as you complete transactions, it's an operation in code speak in TBC, everything is logged here and saved within your project file folder in a zip file. So really helpful for viewing the history, and that's why we've aptly called it history log view. And I'll leave this open and I'll really show you the power of this. You'll be able to see all of our operations and reference them. This is licensed to TBC Advanced, like I said, and available in the current build. All right, so step number 1, inverse command. In the measured distance, this is one of a couple of different commands that we've got. Make it interesting for you. Some may say a little too interesting to find things in TBC. But if you clicked on the ruler with the arrows, that would launch measured distance. If you clicked on the drop-down arrow, that would launch a slew of commands, or give you the option to launch a slew of commands related to measure distance, measure point, measure angle, measure volume, inverse. Inverse, hey, here we go. Inverse is one of the most basic fundamental features that surveyors like to compute. It's also available up top in the quick access toolbar. All right, so here's our inverse command, direction dependent again. If we go from point 101 to point 120, it will instantly compute and be logged in this reported points drop-down list with grid and geodetic azimuths and distances. The difference here is that the grid is exactly what you saw, what it looks like in TBC, in the TBC project, straight line distance from 121 to 120. The geodetic azimuth and the ellipsoid and the ground distances, they follow the geodesic path, which is constantly changing, perpendicular to the relative to the longitudinal line, because the Earth is a curved surface. That's what these geodetic azimuths relate to. That question came up. In the reported points list, if you had 100 different inverse routines here, you can show a report. An HTML report will launch, and here's this routine that we just did from point 101 to 120 with the information that the command reports right there. So you can take this, export it, copy and paste it, save it, take it outside of TBC. All right, the second routine we went through in Trimble Access is the compute points. Close the inverse command. Sure why that's not logging there. Transactions. Anyway. Compute points. In the CAD tab, create points in the dropdown. There are 26 different COGO routines in in TBC. These are, again, it's kind of a split level button on the ribbon where if you click on the top, you get the create points interface. If you click on the drop down, you'll get all of these different routines. And sure enough, we've got a bearing and distance. I believe I had the distance, bearing and distance from 121 to 131. So I will do the same thing. It's prompted me for a reference point. I'll tick that. And it's going to want my bearing right off the bat. See the tracking, angle track. I can snap then 2.131 if I've got my point snaps on. And I can specify my distance of 500. I will then be prompted with the create point interface. So I wanted to code anything, called BD for bearing distance, elevation. I can tag the elevation here at 121. Hit add, and there's my point 1. Now see, the history log went green, the refresh log button. If I click that, here now I get a log of my point 1, the feature code, and these things are dynamic in the sense where you can view point 1, right-click properties, view the properties of this object. If you had, many different points, very complicated job, days and days of data in here, log back to history log that are incremented. These log files are incremented based on your past project saves. So this was me last night prepping this data set. And so if I save this right now, I'll get another incremented landmark. All right. Next up, show the bearing snap. Same interfaces as Trimble Access, right? Reference point, bearing, reference point, and then make sure I can snap. See, I've got point snaps on because I see that little orange circle around point 101. Get the create point interface, point number 2, code it BB, give it an elevation if I want. And there's my point 2. It's centralized based on the intersection of my bearing from 101 to 131, and then 121 to 103 up top. Wanted to refresh the log. There's my point 2 again. All right, routine number 3, average points. So in the survey tab, I'm going to deviate a little bit from Trimble Access here. I'm going to zoom in to point number 4. And in my Project Explorer here on the left, if I expand the points, this Project Explorer is like a log of everything that's in my project in a grouped form. So right now I've just got points in here. If I do the import, if I expand the imported files, I'll see I've got an RTK and resection.job file. That's the job file that we were working with in Trimble Access. You can see there's 4 dark green vectors coming in or coming out of, we'll have to see here, point number 4. If I right click on one and say properties, it sure in fact is a total station observation, and this order matters. So from point 102 to point 4. So based on some, I'll say very simple logic, I've got points here for resection 1, resection 2. I'm going to assume that point number 2 was our station setup. I said there was 1 station setup in this job, and point number 4 was a side shot off of point number 102. One of the beauties of TBC is that you're dealing with the raw data. I'm not dealing with dumb points, CSV points, where I go ahead and play a game of expensive connect the dots here. I wanted to draft from this. virtually impossible to detect any minor blunders. Maybe somebody fat-fingered a rod height or an instrument height, for example, measured up to the wrong distance. All of that information is available here in the total station observation for you to change. Custom prisms can be changed. You can flip and make this observation a backsite for this point. So a lot that you can do and modify with the raw data directly in TBC. One of these benefits is to see how this point number 4 was computed. If you right-click on point 4 in Project Explorer or within the plan view and generate a point derivation report, this will show you how point number 4 is computed. See, here are 3 vectors. They're all face 1. The order of this closed triangle on this little symbol matters. Face 2 would be opening the other way. And based on the computation engine, it uses the side shot observation from the resection 1 2.4, which was total station measurement number 21 in the project, T21. That's used to calculate the grid coordinate and your elevation and height, with the other observations being shown here as deltas. So this was point number 1 to 4. That's on point number 1. This observation right here is used to compute that coordinate. If I disable this, recompute my project, show that again. If I disable it, I need to recompute my project, and I get that notification by this lovely little red circle. I think that's the technical term for it in TBC. That says, hey, user, you need to recompute. You've made some fundamental change. I need to recompute how I'm computing these grid coordinates for my project and my coordinates. I can recompute by clicking on that button in the lower right or in the upper left, or by pressing the F4 key. Now, what did that change? Well, it doesn't appear to have changed very much. Let's run another point derivation point on point number 4. Did I not see it? Disable. Recompute point derivation report, and you'll see the vector from resection 1 to 4 is no longer there. That's because I've disabled it. The comp engine runs through its set of heuristics and hierarchies to then use the next observation available for it, and it tells you right here from point 2 to 4. We are celebrating the 2-year anniversary of, for my money, the best power hour ever completed. It was with Boris and our senior developer, Troy Brown, back in March of 2016 on integrating GNSS, total station level, and user entered data into TBC. That power hour is available for you to watch. It is everything, the nuts and bolts of how TBC computes its coordinates, the rule sets that it uses in the computation engine, and really, really detailed information. Still very, very valid. The nuts and bolts of our software here today is the comp engine. So if you've got any further questions on the computation engine, I would really encourage you to select and view that power hour. All right, got a little sidetrack, but I want to show now the average points and modifying survey points routine. So in Survey tab, go over into COGO, and again, a hidden menu. We make it so much fun. We've got so much in TBC, not enough real estate on everyone's monitors. We've got average points, and then in the drop-down, explode, merge, or rename. I'm going to explode points, and I can select any or all of this data. I just want to explode point number 4. Excuse me, I need to re-enable this vector really quick. And it's detecting that there are, that point 4 is explodable. That means there's more than one observation into point 4. And when I say select point 4, count 3, that's my 3 observations into point number 4, I'll explode. And what happens is TBC will create 3 4 points, point number 4s. Over in Project Explorer, what that means, each one of those observations into point 4 is now separated. Running the average points routine on this, pick and enter a point ID for this averaged point. Let's set this up first. And select your 3 components. What will happen here is a simple mean of the coordinates of point number 4. What you'll also see here, and this speaks to that data confidence, working with the raw data and not just X, Y, Z positions, is, oops, sorry about that. I selected these little pink vectors, and it'll give you the deltas to this average point, which I call 4_average, from each of these components of point number 4. So the delta distance, the azimuth, and the elevation. If I wanted to bring these 3 point number 4s back together, basically undo my explode, I can use the merge point routine. Now, what the merge point routine does is basically sets up the computation engine to recompute your project based on these merge instructions. So the merge point doesn't actually compute anything. That was a big distinction that was kind of a light bulb going off for me when I was working through and prepping this data. It just sets up this resulting point number 4 coordinate to be computed the way that any other coordinate is computed in TBC. So you can also mass select points in your project. If you had a bunch of points that you wanted to merge together individually, there is a filter points by distance. So any point right now, if I had this enabled, within 3 thou of each other would show up here in this resulted list. I'm not super worried about that, but I will take care to not include the average point, which again is an average of these 4 coordinates, these 3 coordinates. And you'll see I've got 3 count of point ID 4. The final coordinate is set. This will just retain the point ID and the quality. It doesn't mean that it's retaining the resulting coordinate. That is from the comp engine heuristics, which I will show. But it is important to note that you have to include which observations you want in this merged point. You can manually select and click in the checkbox, or right-click in the include column and say include all. If I exclude all, I can include all again. Say OK. And oh, look what happened to that average point. It now resides right on top of our merged point because, again, we've taken those 3 observations, merged them into a single observation, and it's taken the average. The average of one coordinate is that resulting coordinate. So I would expect to see 4 and 4 underscore AVG right on top of each other like I'm seeing here. The ultimate resulting coordinate from that merge is controlled by the comp engine. And something I want to say about the comp engine is in project settings, computation, and in the top level computation, there is a side shot computations option. By default, this is set to single observation. So for these total stations, like we were seeing before, any side shot, it will use the first, the order of time. It will use the first observation to that point to compute. You can change that by enabling or disabling vectors like I just did, or you can use these other computation approaches, weighted mean of all observations, weighted mean of like observations, simple mean of all observations, simple mean of like observations. The weighted mean, the weight is distance, so it's an inverse of the distance. The shorter the observation, the more weight it will hold in this. And the difference between all and like observations are of the same type, like RTK or like total stations, for example. So a couple of different options here for the comp engine for you to control how that comp engine is computing your resulting side shots. This is applicable for side shots only. The rules change in the comp engine when you use a station setup, and that's governed by how you selected the station setup, for example. You'll see that my project recomputed right after I didn't really make a change, but after I set a single observation. The reason for that is some commands in TBC do generate that automatic recomputation, and that is one of them. So now, if I run a point derivation on point number 4, you'll see I'm back to my original coordinate and my original hierarchy of resection point 1-4 from resection 1 to point 4 is used to calculate my northern easting and elevation. All right. This is good. We're doing well on time. I've got 2 more to show you. The transformation routine. Sure, in the Edit tab, there are our CAD transformations. Scale, copy, move, rotate. There's even an explode, which is not the same as explode points. Or there's a transform, which is kind of a combination of move, rotate, and scale. But what we're interested in is in survey, is transform survey points. And so this is the equivalent to the transformations routine in Trimble Access. It can be applied via 2 ways. These delta parameters, here's your 7-point transformation, really an 8 if you want to talk about scale, rotation, origin. Or you can do the point-to-point like I showed in Trimble Access, from point to point to compute those deltas. There are 2 calculation methods. The Helmert, which is a more simplified method, it breaks out the 2D and the 3D residuals. So if you had data that didn't have an elevation or a height attribute to it, I would suggest using the Helmert. It's something that can be done from Troy with pen and paper, but for the rest of us, maybe a calculator would be involved. What is a little bit more complex is the least squares method, and that uses all the data type information across your project, much more complicated, much more robust of a solution. And that will also compute horizontal and vertical residuals down below. So the likely transformation or the application for this routine is very similar to site calibration. You know, you're moving or you're fitting coordinates to other coordinates. One application. So if I select everything in my project, I can use set specific transformation parameters. If I just wanted to shift all the survey data up or add any one of these parameters, I can do that. If, for example, I wanted to move everything relative to point 400 over to point 101, and then get another point pair. This is not the greatest of examples, but we'll show the residuals. Instead of compute, something like that. I could use that routine, or I could just use a simple delta northing easting routine if I wanted to move everything up by point by 40. Why everything shifts up, I can view a transformation report. So reporting is a nice functionality, added functionality of TBC, where it just shows that simple translation up 40 feet. All right. Now on to the fifth routine, the subdivide align routine. There's really two commands in TBC that you can replicate that with. We've got the create at intervals. So if I use this, this is more of a point creation routine. So the same exact interface as Trimble Access, same parameters. You can do a selection, like a line selection, or kind of on the fly create your line. Let's say from, what did we say before, 121. Let's go to 101. Specify your interval, say interval at every 50 feet. You can give those point ID, create grid-only points, or make them survey quality, mapping quality, control quality points, able to be transformed and included in the comp engine for future computations. Offset vertical from this line that we've created. Keep it simple and just create these points. Another routine that's a mix of geometry creation and editing and point editing and creation is in Edit tab, divide lines. There is a lot that you can do in this command. I'm going to close the options here just to keep things simple for now. But you set up how you want to do this. I want to divide by number of separate objects or divide by length. So I could do equal segment length. I'll go from our point 121 to 131 up here in 4 segments. This is a line command, so I need a line to pick. Go into CAD real quick and go line string. This interface, we get the comment that drafting in TBC can be improved. I completely agree. But however, one method here, and there's a little tip about this, when you're prompted to fill all these properties out and you say, hey, I just want to draft, well, you can hit enter right through this and click right through it. So it is a little bit quicker than perhaps in past versions. To snap from 121 to 131. Close. Back in my divide line command, I can pick this line for to be divided. And that will instantly, close this command, divide into 4 equal segments. Back into the divide line. Just undo this. Back to my single line. I can create CAD points at each division with a specific symbol. I can create orthogonal lines at each division, which I liked using when I was in the field. I always liked staking out lines rather than points because it gave you a little bit of orientation direction and better navigation relative to that line that I was following in Trimble Access. And I could even create CAD points at the end of that orthogonal line. So I will create an offset of, let's say, 50 feet. I've got my lines to divide selected. Oh, didn't specify how many segments I wanted. There, in the order that I drew the line from 131 down to 121, it's going to create positive 50, which is to the right, like it did. These are orthogonal lines. At a length of 50. Also created these CAD points. There are two different types of points in TBC, and this is my last point. I've got it in the presentation. Won't be able to get to it in this hour, but I've got a nice little chart telling you the differences between what we've called a CAD point, which right here you can see is just a color layer and then an XYZ position, and then the equivalent of a COGO point in an Autodesk application, what TBC just calls a point. And the point is the full functionality, can be feature coded, can be transformed, has underlying transformable coordinate values of local, global, and that grid-based coordinate. So take a look at that presentation. I will make this recording available and have the presentation slides available as well with this data. To work back and forth between CAD points to, from CAD points to points, there's a routine called convert CAD points. And I've got this one CAD point selected. Say OK with a couple of parameters. It will then create this now point rather than CAD point. In my history log, I see this operation here. Here's a series of operations here as well. Let me recompute that. All right. So with that, I'll jump into some questions. Just reading the questions here. Enhancement request from John, thank you. Ross asks, how do I change display from azimuth to bearings? Very good question. Glad this came up. In project settings, in units, azimuth, the very top parameter is display north azimuth. That's the default. You can change that to south azimuth or bearing. So bearing and azimuth are used interchangeably in TBC, but the one that holds and the one that's enterable is, or the, not enterable, but by default, is in this display setting. If you wanted to enter in a bearing, for example, and you've got north azimuth selected, TBC will compute that bearing and translate that into north azimuth. So, for example, if you do the bearing distance, create point routine, select the point. I'll go from 103 down to 1002. This is displayed as bearing. If I change this to, that's displayed as azimuth. If I change this to bearing, the south by east bearing will display. All right, Trevor asked, Michael, could you switch down to that one right below? Is it possible to get the properties of a line segment by clicking on the segment? Let's take a look. Properties. So right now the geometry that we show is for line segments is just minimum elevation, maximum elevation, and length. That's a excellent enhancement request. This was a feature in Terra Model. We are still fighting those Terra Model ghosts, but this is very, very good point. So we will take a look at that, Trevor. Thank you. All right, there's a couple other questions here. I'm running out of time. I will get to you offline. Thank you, Britt and John, and another one from Trevor here. We will get to you offline, but I want to keep this at an hour. All right, so resources and next steps. Trimble Access is a very, very powerful field software. Trimble Business Center is a very, very powerful office software. I hope I was able to sufficiently demonstrate and not fly through too much here within the hour. What myself and other members of the marketing team and the marketing communication team work on day in and day out are these resources available to you to make this knowledge scalable. We're very, very proud of our new TBC webpage. It's a simple URL, trimble.com/TBC. Focused on customer success stories, and I'm very happy to have the TBC overview video on our new website. It's about 120 seconds of everything TBC can do, very, very quickly, very, very succinctly done. If you want a broad overview of what TBC can do in 2 minutes, I would recommend checking that out. The TBC YouTube channel, specifically around new releases, we will post a couple minute, 3, 4, 5, 6 minute videos on what is new, the major new features of a release, along with another awesome monologue of me just talking at some PowerPoint slides, giving an overview of everything that's new. Our development team works very hard on each of these releases. We're aggressively growing our capabilities. And then one of our growing resources and very important resources are these Power Hour sessions. So I don't think anybody will be missing my voice too much, but maybe the content you want to view with the data that we'll be sharing, kind of pause it, take your time with it, see how I've done some of these things. This video, along with any other Power Hour video, and we've been doing them for going on 3 years now, are available via this website. Also available are the other geospatial webinars. RealWorks and eCognition are doing some great things as well. These sessions are all available for free. We've got a public TBC community page that's turned into a blog of end users. It's really encouraging to see end users contacting end users, answering end users' questions. There's also eyes on this from marketing and engineering to answer your questions if your local distribution partner is unable. We also encourage you to use our TBC tip of the week. It's been a pretty positive session. Sessions every Friday, thereabouts. Somebody will post a TBC tip of the week, a little Easter egg, or bet you didn't know that TBC could do this. Real quick session, kind of in a blog format that come out every week, shared on our community page. TBC on Facebook, great for announcements and news. And then our next steps here. If I've intrigued you, if you're not into TBC, if you want to learn a little bit more, encourage you to download TBC from our website and contact your local Trimble distribution partner. We are worldwide here, as exemplified by this diagram. You can get a free 30-day demo license from your local Trimble partner and try us out and use these resources that are available at your disposal. All right, I am got one more slide here. Very, very happy to announce our next Power Hour in April. That Wednesday, April 25th date may be tentative. We may move that up a week. I'm talking with some scheduling conflicts here, but we are very happy to have Andrew Klingenberg, who is a professional engineer licensed at the state of Wyoming. He works for the Wyoming DOT, and he's going to present routing workflows in TBC and how TBC fits in to his workflow with third-party softwares, design softwares, using TBC for some QA/QC, really supplementing and adding value so then he can take that design from the office, from his engineers, into the field to translate it to his surveyors into Trimble Access and be confident that that the design is properly translated into the field. So thank you, Andrew, for doing this. I'm very excited to have you, and look for that registration link here over the next couple of days or so. So with that, I'm going to get some water. I'm surprised my voice hasn't cracked yet, but I do want to thank you for attending. Hope you have a great rest of your day or great rest of your evening, and hope you learned something about COGO routines in Trimble Business Center. Thanks, everyone.